Hi everyone, this is our video presentation for assignment 4 in VideoGr12. I'm Kayla.
And I'm Brandy. Let's get started. Genetically engineered crops aren't new to the agriculture scene. They were first planted on farms in North America in 1996. Yet for a 20-year-old technology, they are sure a hot topic for debate today.
But first, what is a genetically engineered crop? A genetically engineered crop is a crop that has had desirable genes selected, isolated, and then inserted into the genome for a specific purpose. For example, herbicide-tolerant crops, such as certain soybean and canola varieties, allow farmers easier control of weed species. Another example is corn crops, developed with the Bt bacterial gene that protects the plants against larval pests that could cause significant damage. Also, there are genetically engineered, or GE crops, that are nutritionally enhanced, like golden rice, which is high in vitamin A. Genetically engineered crop acreage has increased massively since its introduction in 1996.
There are lots of opportunities and benefits that come from GE crops, yet there is also lots of backlash from consumers. The article we have chosen to talk about today, Experiences and Prospects of Genetically Engineered Crops, sums up a study put out by the NAS, National Academies of Sciences, that aims to weigh out the pros and cons of GE crops. The study concluded that though there are lots of opportunities for GE crops in terms of production efficiencies and global food security, but that consumer opinion and government policy will be the driver of GE crop production. The article says that science has very little to do with the concerns surrounding GE crops, but factors contributing to these concerns are linked to ethics, religion, philosophy, perceptions, and bias.
The effects of genetically engineered crops can be seen at a number of different levels, including directly on the farm, at the consumer level, in the government, and also in international trade. First and foremost, farmers must decide whether or not to adopt genetically engineered crops into their operations. This is largely influenced by how farmers see the costs and benefits as they would relate to their farm.
Each genetically engineered crop has a specific purpose, and oftentimes this changes the input cost associated with the crop and effectively shifts the supply curve rightward. The cost for the seed tends to increase, but improvements can be seen in a variety of other areas. Some of these improvements include reduced chemical needs, such as less chemical needed to control pests due to the genetically engineered crop's ability to fight off the pests, or crops that are resistant to specific chemicals, allowing for less expensive or less toxic pest controls to be used, a reduced need for other forms of pest control such as hand weeding or spot spraying, soil improvement and preservation, which includes increased soil moisture retention, decreased soil erosion, increase in organic matter because of the adoption of minimum to no-till practices as a result of more efficient weed control of herbicides in GE crops, as well as prevention of crop and yield loss as certain GE crops are more resistant to damage and stresses caused by abiotic factors like drought and salinity.
These changes generally mean less money spent on chemical and reduced crop damage from pests and the environment, which offsets the increased seed costs and could potentially improve revenues for farmers. Not all benefits are seen in the field, though. According to the study, the utility derived from genetically engineered crops is largely connected to the household. Well-performing genetically engineered crops have resulted in less time required in the field, allowing many farmers to seek off-farm employment or spend time on other areas, which create a positive benefit for rural communities, according to the NAS study. The demand for genetically engineered crops is not just affected by the producers. It is also affected by the consumers. Consumers have a large impact on the demand for GE crops. Currently, due to misinformation as well as fear and distrust, the anti-GE consumer trend is causing a negative shift in demand, reducing prices and reducing profits seen by farmers growing these GE crops. Consumer pushback is also evident in the consumer advocacy groups and in the change in government policy.
For example, 19 European countries, including Russia, France, Germany, Scotland, Italy, and Austria, have banned the cultivation of GE crops within their borders, though some are still open to GE crop imports. The motivation for banning these crops isn't necessarily based in science, according to multiple sources. For example, France banned the cultivation of GE crops because they believe that they would soil their reputation as the world's food capital. Scotland also admitted that their ban was based on marketing decisions rather than science. These bans that aren't based on science portray a message, whether intentional or not, that GE crops are dangerous because of the enforced ban. This increases consumers' fear and further shifts the demand for GE crop products to the left. This has a negative effect on international trade, making it more challenging for countries to export and increasing costs to ensure that there is no contamination from GE crops.
GE crops are highly regulated by the government, with regulatory authorities ensuring that new crops meet all biosafety standards. In addition, the government uses intellectual property tools to increase investment in and supply of GE technologies and further innovation in the industry. However, some studies have suggested that patents in certain countries could create market failures, as smaller firms may be unable to afford the associated costs, while others can use them to block competition, which reduces innovation.
So, what does this mean for agriculture? Consumers are concerned about where their food comes from, and rightfully so. If they are eating it, they should know what goes into making it. But they need the proper information to make an informed decision, and the majority of info presented about GE crops and food production isn't science-based at all. This is why the scientific and agricultural communities will need to be active in promoting what we do and present the findings that GE crops are safe and are a huge component in future food security. It will also be beneficial to be proactive instead of reactive. Right now, ag is on the defense, when we really need to be on the offensive with this issue regarding food safety and genetically engineered crops. Informing and being an advocate, as coined by Ag More Than Ever, is going to have to be a large part of the agriculture industry.
GE crops need to meet specific standards before they can be grown in, imported in, and consumed in a certain country. Because regulations differ across borders, this creates a major trade barrier. This is especially concerning for Canada because roughly 20% of its farmed acres are allocated to genetically engineered crop production. That is 27.2 million acres as of the 2015 crop year. This is a significant amount of Canadian production, and thus exports for producers to be aware of. This doesn't mean we should stop GE crop production, but it does mean that unless things start to change, GE crop producers may find reduced world demand for their product. As far as the technology of genetically engineered crops, they are very beneficial and a strategic part in feeding the world. Producers are already seeing benefits, such as reduced exposure to toxic chemicals, and are poised to benefit from GE crops that are grown in different climates or soils or that can better handle environmental stresses.
Consumers, too, could see benefits from new crops if the public sector will invest more in those crops that are of public interest. This will all depend greatly on consumer and government behavior and opinion moving forward, though.
To summarize, genetically engineered crops have great potential for growth in the agriculture industry as well as in the world market, provided we as people actively involved in the ag sector get better about promoting what we do and why we do it, which includes promoting the safety of GE crops with the backing of scientific evidence. The article we chose summed it up quite well by saying the science behind GE crops is strong and reliable, which deems that these crops are beneficial. But it is the consumers who will drive demand and the continued usage of genetically engineered crops based on perceptions rather than the facts.
There may be some big changes coming agriculture's way in respect to food production practices with GE crops, unless we educate the consumers about what they are eating and start to debunk a lot of the myths concerning genetically engineered food products. Thanks for listening.